Hi there, Charger family. This is Mrs. Boyd. Today, we're going to be conquering multi-step inequalities. This is a lot like multi-step equations, except for that little bitty fact about moving our inequality around. But we're going to get to that when we come to it. Let's go ahead and get started. We're going to solve each of these inequalities and graph our solutions. So, just like in an equation, we want to get y alone. So to do that, I'm going to add this 22 to each side. Got negative 4y. Those cancel, and that's less than 42. I'm going to divide both sides by negative 4. That cancels. I'm left with y. Dividing by this negative flips our inequality around, and we divide by negative 42. We're going to get negative 10.5. We write this in solution set notation. Y, given that y is greater than negative 10.5. If I put that right here in the center, it's an open circle because there's no equals on our inequality. And since y is on the left and our inequality points in the direction our line is shaded, which will be to the right. Let's do another one, same idea. We've got x this time. To get x alone, we need to first subtract 11 from each side. 2/3 x stays. 11s cancel. Just because we're subtracting doesn't mean we switch our inequality. So it stays just how it is, and that's greater than or equal to negative 18. So now we multiply both sides by the reciprocal. 3's cancel, 2's cancel. Again, you can do this in 2 steps if you'd like. You know what? Let me show you that instead. All right. So first, we will multiply both sides by 3 because that's the opposite of divide by 3. So we're left with 2x is greater than or equal to negative 54. Now we can divide both sides by 2 and get x is greater than or equal to negative 27. Solution set notation, we've got x given that x is greater than or equal to negative 27. Negative 27 is in the center of our line. It's a dot this time because of the equals under the inequality. And again, it's going to point to the right. All the same rules that we've been using continue to apply, but now we just have a few more steps. 7x plus 11 is greater than 3 times 3x minus 1. Always, we're going to distribute first. 7x plus 11 is greater than 9x minus 3. Let's get all the x's together. I'll subtract 7x from each side. 1 is greater than 2x minus 3. I can add 3 to each side. 4 is greater than 2x. Divide by 2, and that gives me 2 is greater than x. If we flip that around and x and 2 trade places, the inequality is pointing at x, so it has to continue to do so. So we have x is less than 2. Solution set notation, x given that x is less than 2. 2's in the center of our line with a circle because there's no equals, and we shade to the left. Another one, number 4, 2 times to distribute. Negative 5y minus 20 is greater than or equal to 3y minus 12. Let's get our constants together, or our variables together. Add 5y to each side. That gives us negative 20. It's greater than or equal to 8y minus 12. Now we add 12 to each side. Whoop, that said 20. It's supposed to say 12. So that's negative 8 greater than or equal to 8y. Divide by 8. And that's negative 1 greater than or equal to y. Let's flip it around. Y and negative 1. It's pointing towards y here, so it's got to point towards y here as well. We can put this in solution set notation. Y given that y is less than or equal to negative 1. Negative 1 goes in the middle. with a dot because it's an equals in the inequality, and it's going to point to the left. Last two on the front here, distribute again. 3m plus 6 is greater than 3m minus 8. Let's get the variables together. That's what I like to do. Whoa! I don't know what that was. So subtract 3m. 3m's cancel. I've got 6 is greater than negative 8. Our variables are all gone. So we have to see if this statement is true. Is 6 greater than negative 8? It sure is. So this is true. Our solution set, our variable m, given that, and our solution, since our statement is true, is all real numbers. My favorite shortcut for all real numbers is an R with an extra line. I will definitely take that. When we shade our line, we're just going to color the whole thing because any of those solutions will be true. All right. Number 6, last one in this group. Distribute first. 24n plus 18 is greater than 24n plus 40. Let's get our n's together again. Got 18 is greater than 40. This is false. This means that nothing that we could ever plug in for n in this inequality would ever be true. So this is no solution, which we're going to show like that. When you put it in set notation, n given that, no solution. I would much rather have this circle with a line through it. When we shade our line, that means we can't shade anything because there's absolutely no value of n that would ever make this true. All right, flip it on over to the back. And we're going to go through some story problems. Nathan has lost his mother's favorite necklace. So he will rent a metal detector to try and find it. A rental company charges a one-time rental fee of $15. $15 one time plus $2 per hour to rent a metal detector. He only has $35 to spend. What's the maximum amount of time he can rent the metal detector? Well, if it's $15 no matter what, that means we're going to have 15 all by itself. And if it's $2 per hour, that means adding on to that 15, we're going to multiply 2 times how many hours he has it to find out how much it costs. If he's got $35 to spend, that means that he needs to spend less than or equal to $35 on this metal detector. We want to know how much time he has. So only one X, we'll leave it there. Subtract this 15 from each side. 15s cancel. So I've got, don't need that. 2x is less than or equal to 20. Sorry, cat laid on the mouse. And then we divide everything by 2. And x is less than or equal to 10. So he can have it less than or equal to 10 hours. Let's write this in solution set notation. X given that x is less than or equal to 10. So Nathan has at most 10 hours to find the necklace. If we put 10 in the center of our number line, it's going to be a circle or a dot filled in because there's an equals included on our inequality. And we're going to shade to the left. Let's do another one. Autumn, Brittany, and Chloe are each 1 year apart in age. The sum of their ages is greater than the age of their mother, who is 54. So this is one of those consecutive integer problems. Autumn is X years old. Brittany's a year older than that. That's X plus 1. And Chloe's a year older than that. That's X plus 2. The sum of their ages is greater than their mom, who's 54. How old can the oldest sister be? All right, so combine like terms. I've got 3x plus 3 is greater than 54 here. You can subtract 3 from each side and get x alone. 3x is greater than 51. Divide by 3. I get x is greater than 17. Solution set, x given that x is greater than 17. So Autumn is 17, is greater than 17. Brittany is greater than 18. And that means Chloe is greater than 19. So if 19 is the center of our number line, we get an empty circle because there's no equals included, and we shade to the right. Putting all the things together. Last one, the area of a rectangular shaped garden. Let's draw a picture. Rectangular garden. It's a rectangle, trust me. The area can be no more than 64 square feet. So the area is less than or equal to 64 square feet. If the length of the garden is 16 feet, well, we know from our years of learning about mathematics that the area of a rectangle is equal to the length times the width. So if our area is less than or equal to 64, then 16 times the width is less than or equal to 64. We can divide both sides by 16. We get the width is less than or equal to 4. Solution set notation, W gives them the W is less than or equal to 4. That means the width of the garden can be no more than 4 feet. If we put this on our number line, 4 gets a dot, and we will shade to the left. I hope these all make sense to you. I hope some number problems help to square these away in your brains, or some word problems, I mean, is the word. I hope you feel free to reach out if you have any problems, and I look forward to seeing you soon.